Today we're looking at domain and range. We've looked at domain and range before, so we're going to start off with a review. Then we're going to go into looking at domain specifically for different types of functions that were given in an equation form. So if you remember domain and range, domain is always left to right, right. Range is low to high. Okay, so if we look at this first one, we're looking at the domain of this. The farthest left it goes is it keeps going on for infinity. The farthest right it goes is it continues on to infinity. So if we write it in interval notation, we would say from negative infinity to infinity. Or if we write it in inequality notation, because x can be everything, this is where we wrote x is an element of all real numbers. The range, we're looking at the lowest it goes to the highest it goes. Here, the lowest anything goes is at -1. It goes up and down, but it never goes down further. These actually go up. I'm sorry, I drew my arrows poorly. It never goes below -1. So the lowest it goes is -1, and it actually hits -1. The highest it goes is +1 because it keeps that wave motion. We're going to use brackets because it actually includes those points, so we use the brackets. If we write this in inequality notation, we're going to say our graph goes from -1 and includes it, so less than or equal to whatever the y value is, which is less than or equal to +1. So y is always in between -1 and +1, including both of those. So if we do these other ones, we've got here for domain, we're looking at x's. The farthest left it goes is 5. The farthest right it goes is infinity. It includes 5. Infinity always gets a parenthesis every single time. So we could say x is greater than or equal to 5. If we look at the range, the lowest it goes is 0. The highest it goes is it continues on towards infinity. So we're going to say infinity. It includes 0, so we're going to put a bracket because it actually touches 0. It starts here at 0, and then it keeps going up while it also goes out. We can say y is greater than or equal to 0. Number 3, we run into kind of a predicament here because we've got these asymptotes. So my graph, if I'm looking at the domain of my graph, the graph goes all the way from the left and it comes towards this x value. We're going to say it's 1, but it never actually touches it. It just keeps going up and up and up. If we pick it up on the other side of the asymptote, my graph is continuing down, always approaching that x value of 1, but it never actually touches it. So when we look at our domain, if we go in interval notation, we say it goes from -infinity to 0, but a parenthesis because it doesn't, to 1, but a parenthesis because it never actually touches 1. We're then going to union that, join it with, it starts back up at 1 with a parenthesis because it never actually touches 1, and then continues on to infinity. That's interval notation. If you want to write it in inequality notation, you can just say x does not equal 1. Which is obviously a little bit simpler, but you need to understand and be able to do both of them. The next thing we're going to look at is the range. So the range, we're going to say the same thing. Let's say this is at a y value of 2, just for fun. So my range, the same thing happens. It goes from -infinity, it goes all the way down, and it comes up to the y value of 2, but it stops. There's an asymptote there. So we're going to have to union that. It picks back up at 2, and then continues on to positive infinity. We're going to pretend like my infinity circles touch. Goes on there. Or again, we can say y is any possible value except for 2. On 4, this is not a function. It does not pass the vertical line test, but we can still find domain and range. We're just going to stick with purple. Domain, the farthest left it goes is -3. The farthest right it goes is +3. So we'd say -3 to 3. Or we'd say -3 less than or equal to x less than or equal to 3. Your range, same thing. The lowest it goes is -3. The highest it goes is +3. So we'll say -3 to 3. Or -3 is less than or equal to y, less than or equal to 3. That should be review, which is why I kind of flew through that a little bit faster. Now we're going to look at what happens when we're looking at equations. There are 3 different types that we're going to concentrate on for right now. We're only going to be looking at the domain of these at this point. So the first kind are fractions. You're going to have an x on the bottom of your fraction. Those are called rational functions. So when you look at them, you're going to write your domain as x is not equal to, or you're going to do your parentheses union your parentheses, because it's going to say everything but that. That's like that third example we did. In order to know what x cannot equal, you need to look and see what makes the denominator equal to 0. Remember, you cannot divide by 0. If you need to pause this so you can write down these notes, that's perfectly fine as well. The next time we'll look at our square root functions, our radical functions. Here, you're always going to write them as x is greater than or equal to, or you're going to have a bracket, comma, infinity, because you want to see what makes that square root equal to 0 and positive. Remember, our square roots have to be positive in order to be real numbers, so we can have the square root of 0, which is 0, so we need to know that 0 value, and what numbers make that square root positive. The combination of the sorts is when you have 1 over or something over on the bottom of your fraction is a square root. You're going to have to combine both those ideas. So you need to find what makes it 0, but you cannot use 0. So instead of having the equal to, it's just going to be greater than, or you use your parenthesis to say not including that number. But you still want to find what makes it 0. You're always looking for that 0. The last thing that's going to come about when we do these, if we happen to have a square term, so if I give you x squared minus 64 or x squared plus 3x plus 5, something like that, you're going to need to factor that. And then if it's a square root or a combination, you're going to need to make a number line. So let's say you factored it and you got your x values to be -2 and +3. You need to decide, can it equal those numbers? If it's just a square root, you would have a closed dot. If it was a combination, you would have to have an open dot. So you would make your dots, decide what they are, and then you need to test a point. You need to decide, do I shade in between them? So does my domain go between -2 and +3? Or do I need to shade outside of them? Is my domain anything negative infinity to -2, or 3 to positive infinity? So you're going to have to make that delineation as you do the problems and work from there. So let's go ahead and do a couple examples of those so you get an idea of what's going on. So the first example we're going to look at is y is equal to 1 over x plus 3. Notice this is a fraction one, so we're going to write our answer as x not equal to. It's a fairly simple one, so we want to say what would make my denominator equal to 0. Well, if I plugged in a -3, that would make my denominator 0, so our domain is going to be x does not equal -3. Or we can write it as -infinity to -3 union -3 to infinity. Okay, simple fraction, just looking at what makes the denominator 0. Second one I want to look at is if we have the square root of x minus 5. The y equals in front. Or an f of x equals, it's all the same thing. So again, we're looking for what makes it 0. So what would make that square root 0? Well, if I plugged a 5 in, 5 would make it 0. But this is a square root, so it can equal 0. It can also be anything that makes it positive. So if I plug in 5, we'll get 0, which is A-OK. If I plug in 6, we'll get 1, which is okay. 7, anything bigger than 5 or equal to 5 makes a positive square root, so everything is fine and dandy. So we already said in our notes this would be a greater than equal to. So since 5 makes it 0, my domain is going to be x is greater than or equal to 5. Or we can write it as everything from 5 to infinity will make this domain valid. All those x values will work in this problem. Another one we can look at is if we have, let's go with red, if we have 1, or let's say g of x equals 1 over x squared minus 64. Here we have a fraction, so we know we're going to use a not equal to. However, we have a squared on the bottom, so we need to factor the bottom. So we're going to write this as 1 over x squared minus 64 factors to x plus 8, x minus 8. So we have two different things that make it 0. Negative 8 makes it 0, and positive 8 makes it 0. So when we do my domain, x cannot be either one of those things. So x does not equal positive 8 or negative 8. We can write it as plus or minus 8. If you did this in interval notation with all your parentheses, it's going to be a little lengthy, but that's okay. It would go negative infinity to negative 8, because that's the smaller one, union negative 8 to positive 8. We're just getting a little bit bigger as we go. Union 8 to infinity. So this shows me it's everything but not negative 8 and not positive 8. The next one, we're going to look at 2 more. I know we're getting a little bit long on time, but these are good for you to see. The next one I want to look at is if we have the square root. Here we have the square root, y equals the square root of x squared minus 64. So again, I gave you the same one to factor, so we're going to rewrite this as y equals the square root of x plus 8 and x minus 8. So again, those values are negative 8 and positive 8, but this is a square root. It can equal anything that makes the square root greater than 0. So what we're going to do is we're going to plot these values on a number line, negative 8 and positive 8. Because it's okay to be negative 8 and positive 8, those would make my square root 0, which is okay. We're going to put a closed dot on both of them. Now we need to test a point. I like to test a point in the middle to see if it works, because then it's either the middle or the outside. So if I test 0, because it's smack dab in the middle, if I do the square root of 0 squared minus 64, this would be the square root of negative 64, which is not okay. We need our square roots to be positive. So this middle part is a no. That means we would shade out here and out here. So as we write this, this would be an or. Because we have a gap, we're going to say x is less than or equal to negative 8, or x is greater than or equal to positive 8. It either has to be smaller than negative 8 or bigger than positive 8. If we want to write this in our parenthesis form, it goes from negative infinity to negative 8, and it's a bracket because we're going to include negative 8, because we had a closed dot there. Union, so that's where our gap is. It's nothing in between negative 8 and positive 8, so it picks back up at positive 8, but including it, because it's a closed dot, to infinity. That's the last one I'm going to do. We'll talk about a couple more in class, but we'll stop there for now. Please make sure you have all these notes written down, and we'll go through and do a few more examples when you get to class tomorrow.